First slide is up. Good morning, everyone. I think I speak for my group when I say we're both anxious and relieved to be going first here. So our panel is titled Risky Business, Adaptive Decision Making. Decision making is inherently risky, especially when you're making decisions that involve wicked problems in the environment. This includes both the built environment, the natural environment, and the people within them. Our panel looks at several different types of risk, like fire, water, and infrastructure, and how we can use tools and technology and policy to help inform decision makers in the future. I'm Alyssa Worsham, and my project is about fire in wilderness areas. And for my project, we'll be bringing together land managers to help inform decisions on how to manage fire in wilderness.
Hi guys, my name is Mariah Phillips, and my project is about quantifying risk of different fires in one specific wilderness area. Most managers currently do this using a couple of software tools that are legally mandated, but those tools are not very accurate at a small scale. So I'm using local forestry data to incorporate something most models currently miss called beetle kill, which we'll talk about in a bit.
Hello everybody, my name is Kolinski, and I will be assessing the microclimate conditions of the forest understory and modeling those conditions to better inform land managers on the adaptive and resilient processes of our forests.
Hi guys, I'm Sydney Murphy, and my project will analyze how development shapes social risk in Antigua and Barbuda. This research is necessary for decision makers in Antigua to build the capacity to cope with climate change.
Hello everyone, my name is Phil. My project will be based out of Tepoztlán, Mexico. I'll be working with a nonprofit called Solar Transformación and developing a decision-making tool for their water and sanitation development initiatives in the region. All of these, my decision-making tool will be a geographic information system-based decision-making tool to help them focus their efforts in the most vulnerable communities across that region. All of these various projects aim to compile relevant and up-to-date data and information into an easily accessible form, a decision-making tool. These decision-making tools will help our stakeholders make data-driven decisions based off of proven best practices. And the hopes is that all of these projects will help the various stakeholders in the region alleviate and adapt to the vulnerabilities and risks in each given context.
Should we use this one? Hi again, I'm Alyssa, and the title of my project is Fire Management in Designated Wilderness, Decision-Making Processes, and Policy Implications. This project is a team effort between me, an MEM student, my research partner, Dagny, who's an MS Ecology student, and our respective advisors, Dr. Melanie Armstrong and Dr. Jonathan Coop. The stakeholders for the project are the Center for Public Lands, which is housed here at Western, and the Aldo Leopold Wilderness Research Institute, which is at the U.S. Forest Service Rocky Mountain Research Station in Montana. And the original inspiration for this project is based on ongoing concerns of wildfire risk in the Powder Wilderness. That's about 30 miles to the southwest of Gunnison, and it's co-managed by the U.S. Forest Service and the Bureau of Land Management, and has experienced some pretty severe beetle kill. Mariah is going to be going into a lot more detail about the science of that, but it brought about some larger questions on how should fire be managed in designated wilderness. So the problem. If you're not familiar, designated wilderness is the most strictly regulated public land in the United States. It must be designated by Congress, and it prohibits the use of mechanized equipment, which makes fire management very difficult. It's also managed by 4 separate agencies, so the Bureau of Land Management, the U.S. Forest Service, the Fish and Wildlife Service, and the National Park Service. And because of this, there's a lack of clear universal policy regarding how to manage fire. So the objective for our project is to compare the policies among the different agencies and look at the similarities and differences in how they both interpret and implement their policy. And then we also hope to look at the specific barriers and opportunities for using prescribed fire in wilderness areas. And why is this important? Well, our wilderness areas, especially in the western United States, are less resilient because of fire exclusion throughout the past century. This is only expected to worsen as climate change intensifies disturbance regimes like wildfire. And therefore, to make more resilient landscapes, we need to be looking at how science and policy inform our decision-making for the future. So again, my burning question, pun intended, is how do we manage fire in designated wilderness? We'll be hoping to answer this question using research that includes both surveys and interviews to collect opinions, experiences, and recommendations from land managers. We had a survey earlier this year where we collected over 130 responses from each of the 4 wilderness management agencies and from every region across the United States, which was pretty impressive. And we're currently conducting and transcribing follow-up interviews to expand on some common themes like fire risk, geographical implications, and also avenues for change. And we are hoping to use the research to inform discussions at an in-person workshop, which will bring together both fire and wilderness managers to create some policy recommendations. And then we hope to publish a peer-reviewed report in addition to some public outreach materials in order to communicate our findings with a wide group of audience types. And in conclusion, I'd like to quote one of our interviewees when asked about the ideal conditions for fire management in designated wilderness. And they said, "It will take years to right this ship. Our heart is in the right place. We just need to get our hands and feet going." And with that, we'll be taking the panel from a 30,000-foot policy level to on-the-ground research, where Mariah will be talking about simulating fire in the Powderhorn Wilderness.
Like Alyssa said, my name is Mariah Phillips, and I have been working on simulating both prescribed fire and wildfire in a local wilderness area about an hour south of town. Both the Forest Service and the BLM manage different portions of this wilderness, and I have been working with the BLM. Unfortunately, the mature conifer forests of this area, which you can see in this lovely picture over on the slide, have been affected by a lot of different insect epidemics recently. With the spruce beetle Dendroctonus rufipennis, you click, awesome, being one of the most damaging. Several of those dead trees that you can see in the foreground of that photo are likely killed by those spruce beetles, and groups of those dead trees are called beetle kill. Insect epidemics like this can worsen wildfire risks, leading to taller flames, faster fire movement over the landscape, more dead trees, and a higher decrease in biodiversity. Wildfires are also occurring more frequently, as Alyssa said, due to climate change, and that's especially bad at high elevation like here. This region historically experienced small patchy fires, which took out little bits of forest and actually led to resilience by creating pockets of different age groups and species variations. However, after a century of fire suppression, we've got a lot of sticks and logs and dead trees accumulated, which set the stage for a singular big wildfire to take out the adult trees, seedlings, and the seedbed all at one time. If that happens, the forest that's currently there probably cannot regenerate. One more click, please. Awesome. And unfortunately, that would probably lead to a different forest growing there or a shrubland growing there, which wouldn't have the same carbon storage or habitat services available. Wildfire could also threaten human infrastructure in the area, including popular hiking trails in the wilderness itself, nearby State Highway 149, and the community of Lake City, which sits about 10 miles further to the south from the wilderness. So what am I doing about it? In the summer of 2021, I gathered 38 sites of forestry field data with a crew of technicians all across the Powderhorn Wilderness and in one area to the north that the BLM had previously identified as candidates for prescribed burning. All right, and the reason that they would burn that would be to consume some of those large fuels like you can see in this plot photo over on your left and decrease some of the availability of trees that can be attacked by that spruce beetle. On the right, you can see a map of the BLM wilderness boundary area. And my study areas, those are the three little outline black areas inside with the study buffers, and the red points are my study areas themselves. You can also see in the photo some of those standing dead Engelmann spruce trees, which pose an especial fire risk because you can see they hang on to their lower dead branches. So a surface fire coming through the area can climb those like a ladder right up the tree and run away as a canopy fire that's really hard for firefighters to control. Since then, I've used several software tools to compare my measured fuel loading to estimates available nationwide through the Land Fire program. If you want to know more about the software that I've used, here are some of their names, and you can ask me more about that later. The next step of my project is talking to several fire modeling professionals in the region and getting some of their feedback to edit my models, and also talking to the Indigenous nations that have already been engaged in some collaborative management on this project. Those are external stakeholders at this moment, including the Ute Mountain Ute, the Southern Ute Tribe, the Ute Tribe of the Uintah and Uri Reservation, and the Navajo Nation, all of whom may have ancestral ties to the area. And then there's also local grazing permittees, recreationalists, and nearby landowners to consider. Internal stakeholders are the USFS, the BLM, and the USFS, BLM, and Colorado Division of Fire Prevention and Control firefighters who might be called upon to actually do the burns that I'm modeling. Awesome. As I am nearing the end of my project, I've already faced a couple different hiccups. My first project actually didn't have funding, so this is my second project. It is okay to do that. I also ended up using 7 modeling programs when I thought I was only going to have to use 2. So do be prepared for scope creep to creep up on you. And leading a crew of technicians in the field was actually a really good challenge that I hadn't had before. I'm thankful to my advisor, Dr. Jonathan Koop. I'm thankful to all of the undergrads who helped me with data collection. And I'm very thankful to my family for supporting me in getting this project done. Continuing on the thought of data-based local place-based management, Shane has been working in Taylor Park using some understory forest data with loggers that I placed in 2020.
Mariah. Hello, everybody. Again, my name is Shane Kolinski, and I'll be modeling surface temperatures of the forest understory in the Taylor Park region of Colorado. So jumping to the project outline here, the big question I'm trying to ask is, how is climate change or rising temperatures going to affect the forest understory, and more specifically, the microclimates of this forest understory? So a microclimate creates a local favorable climate when compared to the greater region or the climate of the region. So when looking at a forest understory, that area may contain lower temperatures and more moisture. So what's the importance of this? Well, when you look at large scale climate models, they fail to recognize some of these smaller local resilient areas within our forest. So if you take a look here down the bottom right hand corner, this is a map of the Taylor Park region with pink triangles placed randomly throughout it. Now those pink triangles, there's between 35 and 40 of them. Some are lost due to malfunctions and environmental factors. But those loggers were placed in 2020 and have been recording the temperature and relative humidity every 30 minutes. So in 2021, they sat out there for a whole year. The data was collected, the loggers were maintenance and redeployed in the area. And here in 2022, I am recording that data off those loggers again and performing maintenance on them to be redeployed back out in the field. So my goal here is to take that temperature data along with the GPS points and elevation of those locations and combine it with another data set, as you can see here in the middle. Now this is satellite imagery of the forest canopy cover in the Taylor Park region. And I plan to take that data and model surface temperature as a function of canopy cover and elevation. And it's the idea that canopy cover and elevation are the 2 best predictor variables when trying to see the temperature variation in the forest understory. And if you take a look here in the bottom left, it's just an example of what the logger actually looks like, that white device, and how they're placed in the field. That shield protects the loggers from different environmental factors such as wind and solar radiation. So they're measuring solely just the atmospheric temperature. And if you take the next slide, and just some challenges that I may face with this project is looking at non-correlated data or non-significant data. It could prove to be or show very little variation within the forest understory. That's something I'll have to attack once I start analyzing the data. And of course, just as expected, programming and software difficulties. But perhaps the biggest challenge I'll face, and it's kind of the basis of my project, is creating an effective and precise model. So it's one thing to have the data sets and see significance and combine them, but it's another thing to use GIS and create a precise model. But with the involvement and the stakeholders that I have along with me in the Western community, I think we can get that done fairly easy. And looking at the Forest Service, we partner with the Center for Public Lands and created a Taylor Park Adaptive Management Group who really made this project possible. So that's all I have for my project, and I just want to say thank you. And we're going to transition more from a natural environment to a built environment and how anthropogenic changes can be modeled and help inform land managers. So with that, I'm going to hand it off to Sydney here.
Thanks, Shane. Hi again, my name is Sydney Murphy, and my project will be using GIS and the MOVE framework to analyze how development patterns in Antigua and Barbuda shape social risk and vulnerability. So Antigua and Barbuda is an independent Commonwealth nation located in the Eastern Caribbean. I myself have been living on the island of Antigua since June of this year, and I'll be living there until next June when the project is done. Antigua and Barbuda are considered highly vulnerable to climate change due to their low capacity or low economic, social, physical, and institutional capacity to deal with climate change hazards. There are many hazards that affect Antigua and Barbuda. The ones that I'm going to be looking at are water scarcity, drought, sea level rise, and tropical storms. You can see the fragility of their built environment through the damage that was done from Hurricane Irma to Barbuda in 2017. For a little insight, Hurricane Irma was a Category 5 hurricane, and just last year, Antigua updated their building code to withstand Category 5 hurricane winds. So it was pretty recent. The four things that I'm looking at to increase adaptation capacity in Antigua in the built environment is first, institutional cooperation between housing agencies, improvement of infrastructure provisions, housing affordability and finances, and understanding land ownership. So as you can understand, this is a very far-reaching, deep-rooted, and complex issue. So how can one person, one MEM student, tackle this wicked problem? So while Antigua and Barbuda need disaster risk reduction and disaster risk management studies and research, the reports that have been done have had a common theme of needs for actions, and those two things are physical hazard mapping as well as social risk assessments. So my project is going to be looking at 4 cities in Antigua. Number 1 is St. John's, which is the most populated, it's the capital. Number 2 is Perham, which is home to critical infrastructure such as desalination plants and power plants. 3 is English Harbor, which is their yachting harbor on the island. And number 4 is Jolly Harbor, which is their resort hub on the island. So to analyze social risk, I'll be using a thinking tool called the MOVE framework, which is a holistic, ground up thinking tool to understand and assess risk, vulnerability, and adaptation in the social realm of Antigua. I was also granted access from the Antigua's Department of Environment to their GIS database to better analyze and understand their physical infrastructure and the exposure that those things might have. My deliverables will be a peer-reviewed publication of my report and findings, as well as a publicly available GIS-based risk assessment decision-making tool. This is all made possible, I believe, by my immersion in the community to understand culture, local needs, and possible solutions that might already exist. Also with the support of my community sponsor and knowledge sharing, which is the Department of Environment and the Antigua and Barbuda National Parks Authority. This is all made possible. I do also want to mention that the National Parks Authority has encouraged me to express that there is much work needed there and a big opportunity for other students like yourselves to continue the work that I'm doing. With that, that's my time. And I want to open the floor up to my colleague, Phil Kern, who's going to be working on water sanitation in Mexico.
Thanks, Sydney. Hello, everyone. I'm going to be talking to you about my project that's
focused on developing a geographic information system decision-making tool for the nonprofit Sorara Grupo, who works on sanitation, water and sanitation issues in Tepoztlán, Mexico, and other regions, but I'll be focused in Tepoztlán, Mexico. Ricardo put me in contact with Sorara Grupo. Actually, if you could go back to that. Put me in contact with Sorara Grupo. They are a nonprofit that right now is focused in Tepoztlán, Mexico. They have a unique methodology in water and sanitation development. Their methodology is focused on 2 points, one being developing self-security and esteem, association with others, resourcefulness, action planning, and responsibility at the community level, wherever they are working. And the other point being developing research and development of appropriate technologies that the community can manage and maintain well after the nonprofit has left without any external inputs. And the goal is to have a community-driven program where individuals within these communities are going out and doing surveys, gathering data that will then be sent to Western, hopefully in a geographic information system class taught here, where data can be continuously put into this decision-making tool. So they focus on decentralized water and sanitation systems. Decentralized water and sanitation systems are systems that can be operated on the household level or in clusters of household. It's different than what we're used to, where a bunch of different homes are all connected to the same system to where it goes to a plant, very energy intensive and resource intensive in general. So these systems, these are just 2 examples. There's a bunch of different technologies out there. Right here on the left, this is a slow sand filter attached to a rainwater harvesting system. And on the right, this is a urine and fecal matter diverting separating toilet where compost is created, as well as fertilizer for tree gardens or any other kinds of gardens.
Well, they've recorded it.
So these are some examples. They're not my project, but these are examples of what I'm trying to create. In Tepoztlán, there's about 110 different localidades within like a county. And I want to create a map of vulnerabilities using census data and possibly data that we can gather in the field to create a vulnerabilities assessment of each county to help Sorara Grupo figure out what counties they want to work on next. Right now, they're focused in Tlacotenco, which is where I will be spending most of my time in this project. And the second map that I'm going to create is like the one on the right, where it's a comprehensive map of Tlacotenco. Each household should be included in it, and it will help Sorara Grupo figure out what neighborhood they want to initiate the next project.
We're doing what we can. In
So
that
the survey
area,
will
Washington,
include information
right
like,
now, it's not possible. but
do you have access to
we've
clean
got
water? If so, how many hours a day do you spend getting it? And how much
Okay, well,
what percentage of your income do you spend on your water? Do you have access to sanitation
want to watch
systems?
this.
What kind? And the hope is that through compensation, we'll be able to train and pay members within this community to go out, do the survey. So it's not just a foreigner knocking on the door asking questions about how they handle their human waste. This project will definitely need to be continued. There's a bunch of different options for it. You could do rainwater potential analysis, or take the same project and implement it in the next county or town that they want to work in. And with that, that kind of completes my project.
Time for questions, and also I would like also the panelists to invite or to highlight when there are opportunities for first-year students to continue your projects, and also for the audience to highlight how these projects could continue. So questions, this is the time for that. And when we have a question, the person who will answer, please repeat the question so that the audience in Zoom can listen to it, please. Yes.
Yeah, Alyssa, I'm just curious, you had mentioned that you were hoping to have the possibility of prescribed burning in these areas in the future. What do you think the likelihood is of that? And if it were to happen, do you think you'd be able to include indigenous traditions into that prescribed burning process?
So Leah asked, what's the likelihood of prescribed burns actually happening in wilderness areas, and if possible, using indigenous traditional knowledge to do so? So as I said, we've been interviewing a lot of people right now, and so far yes, prescribed burning is happening in wilderness areas. It's primarily in the Midwest and the East Coast. They're a lot more comfortable with fire out there is what we've learned so far. And specifically, I just talked to someone in Minnesota, and they do work with the Ojibwe peoples up there. And so that is happening. In the West, there is a bigger, it's harder to do fire, especially when it escapes, and there's a lot of political stuff around that. But yeah, I think there is an opportunity for that, and we're trying to include those voices in both our publication and in our in-person workshop.
Sydney, you have a couple different value systems you're looking at with your vulnerability and adaptation. Curious how you're weighing those values and essential for communities versus essential.
Yeah, good question. Jojo asked where I hold value in assessing risk.
No, the values that you're assessing in different places, like the yacht versus like the desalination plant, having totally different values to the community. Like, how are you weighing those different value systems?
Oh, okay. Yeah. Well, actually, I guess to answer that, she asked, how am I weighing different values of the different places that I'm studying? And they're all equal. So that's kind of how I picked those 4 areas because of their equal contribution to the social health and well-being of Antiguan people. Tourism is huge in that country. I mean, it's 90% of their economic stability. So that's why the yachting and recreation hubs are really important. And the commercial and population mostly live in St. John, so that's where people physically are. And Parham is critical infrastructure like water and power. So especially looking at the MOVE framework and hazard mapping, those 4 things are really important to human well-being and success of the country.
Would everyone please mute their mics?
Sydney, I also have a question for you. I was just wondering how you found this project, and like if you have ties to Antigua, or how you found yourself in this position.
Yeah, I definitely had ties to Antigua and had the opportunity to move down there. I've always been interested in community development and sea level rise specifically. So when the opportunity presented itself, I really pushed for making it work and contacted everyone down there to see if there was a necessity for me, and there was. So it all kind of fell into place. Yeah. Oh, I didn't repeat the question.
My question is for Phil. I'm curious about the fecal and human waste filtering system that was in the photo on the right. Can you talk a little bit more about how that works?
Yeah, so he's asking about one of the technologies that I posted on the slide. So you said filter. It's actually a urine and fecal matter separating toilet. It's called a dry toilet. So that toilet, your urine is separated and goes one way, and then your fecal matter goes into a lined composting area that's ventilated, and that compost, it takes a while. It takes like maybe 2 years for human waste to compost, but there's usually rotating versions of that toilet. So after a year of that one, they'll go to the next one and then the next, and your urine is actually where most of the nutrients like that are removed in our plants here stays. So that is stored for a short period of time where it's kind of stabilized and then used as fertilizer itself. So the urine
is used as a fertilizer. They're both a lot easier to treat once you separate them. And that's kind of counterintuitive to what we think of. And it uses zero water too. So it doesn't use any water and creates a resource for the community, and also closes the nutrient cycle, the nitrogen cycle. And that's kind of the whole point of wastewater treatment, is to close the nitrogen cycle so you don't have nitrification in local rivers, as well as pathogens in the community. Did that answer the question?
With this, we have to close this panel, and a big applause for this group.